Hey guys, so I am recording this video for the second time because for some reason when I recorded it the other day, the volume didn't record. So let's try this lesson again, even though it's your first time ever hearing it. So we are going to do a couple more examples like yesterday, and then we're going to learn how to factor trinomials where the a values are not going to be 1. So that does make the factoring process a little bit longer, but you guys are definitely still capable of these type of examples. So if you wanted to pick up with yesterday's notes, you can, or you can just start from scratch. So our goal is still to factor the following quadratic examples. Give me 1 second, my headset's falling out. All right. So our goal is just to factor. I'm going to put 2 on the board. I'm going to have you guys hit pause after I write them, try them on your own, and compare them with my work and explanation. See if they match. Okay, so hit pause. For the first one, there's just 2 terms there. It's not a trinomial. What I would want you guys to notice is that there are common factors. So the GCF of the first problem will be a 3x. So we are going to factor a 3x out of both terms. If I do that, I'm dividing everything by 3 and removing an x, which will leave me with x minus 3. That's as far as that problem goes. There's no longer any quadratics left. Everything is linear factors. For example number 2, it is a trinomial with an a value of 1. So we're going to go ahead and find factors of 56. So 1 and 56. 2 and 28, and I'm going to jump to the one that's going to work, which is going to be 7 and 8. My goal is to find the pair that when I combine them can give me a positive 1 here in the center, which will be 7 and 8. My factors are going to be x plus 8 and x minus 7, because 8 minus 7 is positive 1, and 8 times negative 7 is negative 56. Remember, when the C term is negative, you need 1 of each sign in your factors. All right, so this third example, we're going to work together. It's going to follow the same process as yesterday. However, just look a little scarier, but same idea. We're going to throw in an extra variable here. So we're throwing in this b variable. Because the leading coefficient is still a 1, we're going to start by finding the factors of C. So factors of 72 that are going to add to the 38 in the center. So 1 and 72, 2 and 36, and I'm going to stop because right there, that's the winning pair. 2 and 36 can add to 38. The only difference is when you're setting up your 2 factors, to get the 1a squared, you'll have a and a, and to get the 72b squared, we're going to have 2b and 36b, because the b times b will give you the b squared. Everything is addition, so no negatives anywhere. If you wanted to check to make sure that that worked with the inner and the outer, you would have 36ab plus 2ba, but ba is the same as ab, which will give you that 38ab in the center. It does match up. So this is our factored example. All of the rest of examples that we're going to do today are not going to have an a value of 1. Okay, so the goal for these, so we're factoring trinomials when a doesn't equal 1. Okay, yesterday, all the a values were 1, or there was a GCF first. When doing this, not only do we have to find factors of C, but we also have to find factors of A. So we are going to find factors of A and C that when those factors are multiplied, combine to B. All right, so there's a little twist there because of the A value. The first example we're going to do is actually from last night's homework. So question number 15 from last night's homework is a lead-in to this skill. So a little more guessing and checking will be involved. So if we set up our factor pairs, A value is 2, not 1, and there's no GCF here to be able to factor out first. So the factors of 2 are 1 and 2, and then you still find your factors of C, 1 and 3. The big difference is you'll see that the factors of C will not combine to your B value of 7. They won't. That doesn't mean this is not factorable though, because the A value is not 1. So the only way to get a 2x squared is to have a 2x and a 1x. Those come from the factors of A, 2 and 1, 2x, 1x. And then the only way to get a 3 at the end is to have a factors of 1 and 3. But these are not identical here. So therefore, where the 1 and the 3 go matter. It could be 1 and 3, or it can be 3 and 1. So you have to be willing to make a guess, check your guess, and if it doesn't work, guess again until you find the combination that does work. You can do a little mental math thinking. The stronger you are with your multiplication facts, the quicker factoring goes for you. You can think, well, 2x times something over here has to get me close to the 7x. So you might try putting the 3 over here because 2 times 3 is 6, which is close to 7. If you put the 3 here, the 1 is going to go over here. Check your signs. Everything's positive, so we will have a plus and a plus. Let's go ahead and check this to see if this factorization works. If you check the outer and the inner, we're going to get 6x plus 1x, which does equal positive 7x. If that did not work, you would then try switching the 1 and the 3. So put the 3 in the first factor and the 1 in the second factor and check to see if that works. The students who struggle with these type of factoring problems are the ones who are not willing to make a guess, that just stare at the problem for a long time rather than just starting it. Making that initial guess, checking it. If it doesn't work, like I said, you just keep guessing, keep guessing, keep guessing, and keep checking until it does work. So we'll do more examples of these in our notes today. We have a total of 5 going in your notebook. So here is our first example. 7x squared minus 4x minus 3. We're going to set up our factors and find the factors of A and C. So 7 doesn't have a lot of options. It's just 1 and 7. It's prime. Same with 3, 1 and 3. Anytime I give you a prime number, there's definitely a lot less guessing to do. So the only way to get 7x squared is a 1 and a 7. So I'm going to put the 7x and the 1x as the first term in each factor. And now I have to be willing to make a guess of 1 and 3 or 3 and 1. Keep in mind that 7 is going to be multiplied by something over here. I probably don't want to put the 3 here because 7 times 3 is 21, which is a lot bigger than negative 4. So I'm going to put the 1 over here and the 3 over here. I'm purposely going to put the signs in the wrong spots for this example. When the C is negative, you have to have one of each sign. And I want to show you what will happen if the signs are incorrect. So if I put the negative here and the positive here, and I check my guess, so I check my outer and my inner, I will get positive 7x minus 3x, which is positive 4x. If I look back at the original problem, this was a negative 4x. That does not match, but it means you're really close. All you have to do is switch your signs. So instead of putting the negative first and then the positive, it's going to be positive and then negative. If you check your inner and outer again, it should work. Negative 7x plus 3x is negative 4x, and that does match up. Therefore, this is our winning combination of factors. 7x plus 3 times x minus 1. Okay, here's our next one. 2x squared plus 19x plus 9. The same process again. Find the factors of A, just 1 and 2, so that means I'm going to have a 2x and a 1x. And factors of C, this time I can have 1 and 9 or 3 and 3. A little more guessing involved here. It could be 1 and 9, it could be 9 and 1, or it can be 3 and 3. So that's 3 different guesses. Go ahead and just make an initial guess. I'm going to show you what happens when you guess wrong. I'm going to put 9 and 1. Everything's positive. And if I check my outer inner, I'll get 2x plus 9x, which is 11x. Does not match with the 19x. So you guess again. Instead of doing 9 and 1, switch and do 1 and 9. I always would switch the numbers before you move on to the 3 and the 3. So I'm going to put the 1 here, the 9 here. This probably would have been my first guess, just because I know that 2 times 9 is 18, and 18 is close to 19. So you can really try to think logically about it before you make that first guess. But if you struggle with that, then just make a guess, check it, keep guessing, keep checking. If I check this, my outer inner, I will get 18x plus 1x, which is 19x, and that checks out. Okay. 6x squared minus 26x plus 28. Looking at this example, I would hope that you guys would notice that this first has a GCF of 2. GCFs are always the first part of factoring before you try to do anything else. So I'm dividing them all by 2 and factoring out the 2. Now I'm going to go ahead and guess and check with this inner trinomial. I'm going to put a box around my GCF just so I don't forget about it, and then start my guessing and checking. Factors of 3, still a prime number, so it's just 3 and 1. And 14 can be 1 and 14 or 2 and 7. Now, even though 1 and 14 combine to 13, that doesn't mean that that's the winning pair. Because remember, when the A value is not 1, a lot of the time, the C terms do not end up, the factors of C do not end up combining to B. So we have to make a guess. I probably would not put the 14 all the way over here, because 3 times 14 is a huge number. If I put the 1 over there, 3 times 1 is 3. Not really super close to 13. If I put the 7 over there, 3 times 7 is 21, a little too big. If I put the 2 over there, 3 times 2 is 6. Still not super close to the 13, but that one I think, in my opinion, would be my best bet. Because I know if I put the 2 here, which will give me a 6, and the 7 here, I know 6 and 7 can give me 13. When the C term is positive, that means our signs have to be the same in our factors. So if we look at the middle, because it's negative, these are both going to be negative. I'm also going to bring down my GCF and check. So if I check my outer and my inner, I will get negative 6x minus 7x, which does equal negative 13x. If you do not bring down that GCF of 2, then when you redistribute the 3x minus 7 times the x minus 2, you will only get this trinomial right here, the 3x squared. Remember, you're always supposed to get back to the original, which started with a 6x squared. Without that 2, you would not get back to the original problem. That's our answer. Okay, after I write this fourth one on the board, I'm going to have you guys try it on your own. I'm going to have you hit pause and then check your answer with my answer. Factors of 3 are just 3 and 1. Factors of 10, 1 and 10, 2 and 5. I'm trying to get to a 13. If I put the 1 and the 10, 3 times 10 is 30. To me, that's too big. I could put the 10 and the 1. 3 times 1 is 3. And then the 10 over here could get me 13. However, I would need the signs to be the same. And the C is negative, so they can't be the same. So that won't work. The winning pair, I'm going to put the 5 over here to get 15. and I know 15 and 2 can give me 13 if I subtract. So I want a positive 15 and then minus 2. If I check my outer inner, I will get 15x minus 2x, which is 13x. I've been factoring for years, so believe me, it's okay if you guess wrong. I'd rather you guess, check it, and keep guessing and getting the right answer than just stare and leave it blank. But the good thing about factoring is you can always check. Okay, so this is the last example for today. And then the rest of the video, I will have just a couple more examples for tomorrow, from tomorrow's lesson and the day after lesson. So, but this will be the last example for today. 6x squared plus 7x minus 5. This one's a little more challenging because instead of the a being prime, it has two options. It could be 1 and 6 or 2 and 3. But the c is prime. The only way to get 5 is 1 and 5. So there's more options for the first term in each factor versus the last term in each factor. So I'm going to start backwards. I know that if I want to get a c term of 5, I have to have a 1 and a 5. The c term is negative, so I know I need one of each sign, and I might have to change my signs later. That's okay. Just making a guess right now. And now for the first term, it could be either 1 and 6, 6 and 1, 2 and 3, or 3 and 2. That's 4 different guesses. I'm going to go ahead and make an initial guess, trying to get a positive 7 when I check my inner and outer. Definitely don't want to put the 6 first, because I know 6 times 5 will give me 30, which is way too big. So I know 6 and 1, in my opinion, would be out. 1 and 6, I could put that there, but I know if I put the 1 first, that'll give me 5 times 1, which is 5, and then I'll get a 6 in the middle, and 5 and 6 can't give me 7. So I'm not even going to try guessing that. I'm going to try with the 2 and the 3. I'll put the 2 here, 2x, because 2 times 5 is 10. And I'll put the 3 here, and 10 and 3 can give me 7. And I know it's going to be a 3 because it's 1 times 3. If I go ahead and check my outer and inner, I'm going to get negative 10x plus 3x, which is negative 7x. That's close, but not quite. Ooh, and I also forgot my x here because my sign's wrong. I want a positive 7x, so I need to go ahead and switch my signs, make this one negative and this one positive. If I check again, just to be certain, now I'll get positive 10x minus 3x, which does equal positive 7x. So that's my winning combination. All right. So at this point, you guys will have whatever time is remaining in class to start your homework. So it's a practice and a homework worksheet. And then the rest of this video will be a clip from tomorrow's lesson, and then a clip from the next lesson after that. So day 3 and day 4 lesson. I will see you guys later. All right, so even though this is part of day 2's video, this is actually an example from day 3. So I'm going to go ahead and do with you guys just a formal summary of the difference when we're factoring when a equals 1. Okay, so we're going to compare the factoring process when a equals 1 versus when a doesn't equal 1. So what we were doing on the last 2 days. So the day 1, the a values were all 1. Those were a lot easier. And day 2, the a values weren't 1. So if I gave you x squared minus 11x plus 18, and we will compare that to 2x squared minus 5x minus 12. In the first example, when the a value is 1, you only have to worry about finding factors of c. Oops, not 4, 3, and 6. And when the a value is 1, the factor pairs will combine to the b term. Okay, they will combine to b. So I want 2 and 9 because I know 2 and 9 can give me that 11 in the middle. C term is positive, so same sign. The sign rules are the same for whether A is 1 or A is not 1. And because the middle term is negative, they're both going to be negative. When the A value is 1, I just put x and x, because x times x is 1x squared. And then because these factors so far are identical, it does not matter where you put the 2 or the 9. Sometimes it does matter if the signs are different, because you've got to get a very specific sign for your middle B term. That's it on that one. When A doesn't equal 1, you also have to find factors of A, not just C. So we set this up. A is prime, so it's not too bad. So the only way to get 2x squared is a 2x and a 1x. But then it could be 1 and 12, 12 and 1, 2 and 6, 6 and 2, 3 and 4, or 4 and 3. Okay, that is a total of 6 different guesses that we have to try. Think about it logically. Our goal is to get this B term. And those factors of C will not combine to the B value because the A value is not 1. That's the big difference between the two. I have to be willing to make my guess and check my guess. So I'm going to guess, looking at all these factor pairs, trying to get close to 5. I usually like to start with this space right here. 2 times something used to get me semi-close to 5. 2 times 1, 2 times 12, 2 times 2, 2 times 6, 2 times 3, 2 times 4. Now 2 times 2 is 4, which is close to 5, but 5 and 6 won't give me 5. So I want to be a little bit farther away. So I'm going to go ahead, and you guys could play around with this and hit pause if you'd like to. So I'm about to tell you the winning combination. It's going to be 4 and then 3. Because 2 times 4 is 8, and then I know 8 and 3 can give me 5. I want a negative 5, so therefore I'm going to want a negative 8 and a plus 3. If I check my outer inner, I will get negative 8x plus 3x, which is negative 5x. Don't forget to check your guess, because if your guess is wrong, you got to guess again. So that's a summary there on how to distinguish the difference in factoring when A equals 1 versus when A doesn't equal 1. You guys can hit pause because the next example that I'm going to do is from tomorrow's lesson. The rest of today, you guys are going to work on one of those scavenger activities where in pairs you're going to start at a particular problem, do the factoring, and the answer will be on the bottom of another piece of paper. All right, so hit pause. So this will be part of day 4's lesson. You guys just looked at a handout, and you did the front page of the handout together. And I would like you to put one example in your notebook. Just in case you lose this paper, at least you have, well, you shouldn't lose it, but at least you'll have one in your actual binder that you can reference if you get stuck. So this is the one I would like you to write down. And the goal of today is to factor using the grouping method. Okay, that's what you just learned how to do on that handout, and you guys are going to do a couple more together. So the example that we're going to do in your notebooks is 3x squared plus 48x minus 30. So 3 is prime, but 30 has a couple factor pairs. Totally could do this by guessing and checking. I mean, that's my personal preference. But if you're guessing and checking and nothing's working and you're like, there's too many guesses here, this is another strategy that you can use. But I only want you using this grouping strategy when A and C have lots of factor options. Okay, I'm talking about maybe 6 guesses or so. So between A and C, there's a total of like 6 factor pairs there between A and C. So grouping method, you're going to start off by multiplying A times C. 3 times negative 30 is negative 90. And the B goes below it, positive 48. Signs do matter. And we're trying to find 2 numbers that multiply to negative 90 and add to 48. I suggest you just start dividing 90 by stuff. 90 divided by 1, 1 and 90 cannot give you 48. 90 divided by 2 is 45. So 2 and 45, oops, that's not supposed to be a 48. That's why it's not going to work. Sorry, guys, this is supposed to be a 43. I'm like, that was supposed to be the winning one. not 48. I can't read my own writing. So 2 and 45 is the one that works. I want a positive 45 and a negative 2. 45 minus 2 is 43, and 45 times negative 2 is negative 90. If that wasn't the winning one, then you do 90 divided by 3, 90 divided by 4, 90 divided by 5, etc., until you find the pair that works. We drop down the A term, and we break apart our B term. We're uncombining like terms. Instead of writing positive 43x, we're going to write positive 45x minus 2x, and then drop down your C. We split the problem in half, and we go ahead and do the GCF of each side. So we're like factoring individually here. On the left side, my GCF is 3x, so I'm dividing everything by 3 and removing an x, leaving me with x plus 15. And the right side, when the leading term is negative, you factor out a negative, so I'm factoring out a negative 2. There's nothing in common. Remember, you've got to factor out a 1 at least. When you factor out negatives, your signs also change. You know you're doing it right when you have an identical factor on both sides. That becomes factor number 1. You do not write it twice because you're essentially removing that as the GCF. You're pulling the x plus 15 from both sides, leaving you with the 3x and the minus 2, which becomes factor pair number 2. So that is factoring by grouping, which we use as a last resort method if guessing and checking is taking too long and there's too many guesses to be made. So you guys are going to go back to the handout, do a couple more together, and then whatever class time is left, you guys are going to go ahead and work on the practice worksheet, which you'll have to finish for homework. Tomorrow we're going to learn some shortcut and some special cases to factoring certain quadratics. Bye, guys.